Imagine waking up tomorrow morning. You look at the clock, and somehow only 1 second has passed for you, but for everyone else in the world, 1,000 years have gone by. Or maybe you spend just a few minutes inside a spaceship, and when you come back to Earth, nobody you knew is there anymore. Maybe the cities have changed. Maybe entire countries are gone. Maybe human civilization looks completely different. And maybe you're the only thing that hasn't changed. This isn't just some sci-fi story. Physics actually tells us that time doesn't pass the same way for everyone. Speed can change how fast time passes. Gravity can change it too. And once we get down to the quantum level, even the simple ideas of before and after can get way stranger than we expect. But here's the real question. If time can slow down, can it actually stop? And if it can stop, could we somehow make it run backward? We live with time every single day. The alarm goes off. Morning turns into night. Meetings start. People get older. Everything around us changes. But there's one simple question that's actually incredibly hard to answer. What exactly is time? If we have a ruler, we can measure its length. If we have an object, we can measure its mass. But we can't put time on a table and look at it. We only see things changing. The hands on a clock move. The sun moves across the sky. Our bodies get older. And we use the word time to describe all of that change. Maybe that's why time is one of the strangest things in the universe. It's everywhere. But nobody can really point to it and say, that's time. We usually think of the universe as having 3 dimensions: length, width, height. But if we want to describe exactly where something happened, those 3 aren't enough. We also need to know when it happened. For example, saying a spaceship is 1,000 kilometers away from Earth doesn't tell us everything. We also need to know when we measured that distance. That's why, in modern physics, time is part of something called space-time. Space and time aren't completely separate things, but there's something weird about time. In space, we can move forward, we can move backward, we can go left, we can go right, but in our everyday experience, time seems to have only one direction, from the past toward the future. And that brings us to one of the biggest mysteries in physics. Why does time seem to move only forward? A lot of the basic laws of physics still work mathematically if you reverse the direction of time. But the real world doesn't seem to behave that way. Drop a glass, and it shatters. But the pieces don't suddenly jump off the floor and put themselves back together. Leave a piece of ice in a warm room, and it melts. But the water doesn't normally pull heat out of the room and magically turn itself back into the exact same piece of ice. Why? One of the biggest clues comes from the second law of thermodynamics, and a concept called entropy. In simple terms, in a closed system, entropy tends to increase. The universe naturally moves toward states that have more possible arrangements. And this increase in entropy is one of the main reasons we experience something called the arrow of time. But that's still not the whole story, because if time always moves forward, why did Einstein show that speed and gravity can actually affect how it passes? This is where relativity comes in. Imagine we have 2 identical clocks. One stays here on Earth. The other is placed inside a spaceship moving extremely fast. When that spaceship comes back, the 2 clocks might not show exactly the same amount of time. And no, the clocks aren't broken. It's not a battery problem. Time itself has passed differently along those 2 paths. That's called time dilation. Now imagine a spaceship that could travel incredibly close to the speed of light. For the person inside the spaceship, everything feels completely normal. Their heart is beating normally. Their clock is ticking normally. They don't feel like time is slowing down, but when they return to Earth, they might discover that way more time has passed for everyone who stayed behind. Imagine you experience only a few years of travel, but when you come back, decades, or even centuries, have passed on Earth. In that sense, you've traveled into the future, and you didn't need some crazy sci-fi time machine. You just used the laws of physics. But now we get to the really interesting question. If we can travel into the future, can we travel back into the past? This is where things get a lot more complicated. Because going back in time isn't just a physics problem, it's also a logic problem. Imagine you somehow travel back into the past and do something that prevents yourself from ever being born. Then who went back in time if you were never born? Who caused the whole thing to happen? That's the kind of problem known as a time paradox. And these paradoxes are one reason traveling into the past is so much more complicated than traveling into the future. But does physics completely rule it out? Not exactly. Some solutions to Einstein's equations allow for incredibly strange structures in spacetime. One of the most famous ideas is wormholes. Think of a wormhole as a hypothetical shortcut through spacetime. Imagine 2 points that are really far apart on a sheet of paper. If you travel across the surface, the distance could be huge. But now imagine folding the paper, bringing those 2 points close together, and making a tunnel between them. From the outside, the journey is incredibly long, but through the tunnel, it could be much shorter. That's roughly the idea behind a wormhole, a shortcut through spacetime. But there's a huge problem. We have no direct evidence that traversable wormholes actually exist. And even if they do, we have no idea how to create one or keep one open. Some theoretical models require extremely strange conditions, including something like negative energy. And we still don't know whether anything like that could be produced and controlled on the scale we'd need. So for now, wormholes are a fascinating theoretical possibility, not a real-time travel machine sitting in somebody's garage. But things get even stranger when we enter the quantum world. At extremely tiny scales, nature behaves in ways that don't really match our everyday experience. Some quantum experiments even suggest that the order of certain events isn't always as simple as we imagine. That doesn't mean we can jump into a time machine tomorrow and visit the past. Not at all. But it does tell us something important. Our everyday picture of time might not be the full story. Maybe time at the deepest level of reality is much more complicated than a simple line from past to future. And that leads to an even stranger question. Maybe time isn't actually something that flows. Maybe the past, present, and future are all part of the structure of spacetime. And what we experience as the passing of time is connected to the way our brains experience and organize events. That still doesn't mean we can casually jump between the past and the future. But it raises an old question again. Does the future already exist? Or is only the past real, while the future hasn't happened yet? And this is where physics starts getting really close to philosophy. Because whatever answer we find, it leads to an even bigger question. If traveling into the past were really possible, why haven't we ever seen anyone from the future? Why hasn't someone shown up from hundreds of years ahead with a time machine and told us what happens? Maybe traveling to the past is simply impossible. Maybe the laws of nature don't allow it. Maybe time paradoxes prevent it. Or maybe we just don't understand the physics of time well enough yet. And that might be the most important part of the whole story. We still don't know exactly where time comes from. In relativity, time is part of spacetime. In quantum mechanics, things get much stranger. And when we try to combine gravity with quantum physics into one complete theory, we still don't have the final answer, which means the deepest mystery about time could be hiding inside a piece of physics we haven't figured out yet. So can we travel into the future? Yes. In a real scientific sense, it's already possible. The faster you move, or the stronger the gravitational field, the bigger the difference in how much time passes for you compared with someone else. But traveling into the past, that's a completely different story. Some theoretical models leave the door slightly open, but we have no working technology that can take us there, and we have no reliable evidence that any human, or any other large object, has ever traveled backward through time, and maybe it never will. But now imagine that one day technology gets to the point where we can send a spaceship incredibly close to the speed of light. You step inside, the door closes, the engines start, Earth slowly gets smaller behind you, you spend a few years traveling, and then you come back. But Earth isn't the same anymore. The people you knew might have been gone for generations. The cities could look completely different. Civilization might have changed beyond recognition. And you, without feeling like you've aged any faster than normal, have arrived in a future that took everyone else centuries to reach. That might be one of the strangest things physics allows us to imagine. We don't necessarily need a magical time machine to travel into the future. The universe already gives us a way to do it. We just need to move fast enough. But the past, that's a different story. Maybe the past isn't a place we can return to. Maybe it's information that has spread through the universe. Light leaving a star millions of years ago, and finally reaching our eyes today. The trace of an event that happened a very long time ago, still traveling through space, even though the event itself is long gone. And that might be why, when we look up at the night sky, we're actually looking into the past. That star you're looking at tonight might not even exist anymore in the way you see it. Its light could have been traveling toward us for years, or even millions of years. The past is still out there. We just can't step inside it. We can see its light, we can measure its effects, we can study what happened, but we can't reach out and live that exact moment again. And maybe that's one of the most beautiful things about time. Every moment you're experiencing right now is already becoming the past. Not tomorrow, not a few hours from now. Right now, the sentence you're hearing has already happened. And at this exact moment, the next second hasn't happened yet. We're always living on this strange boundary between the past and the future. We call it the present. But maybe the present isn't really a single point. Maybe it's just the tiny slice of reality our consciousness is able to experience. And that might be why the more we ask questions about time, the less certain we become about what it actually is. We still don't know whether time is something fundamental to the universe, or whether it somehow emerges from deeper laws of physics that we haven't discovered yet. We don't know why time seems to have one direction. We don't know why the past feels so different from the future. We don't know whether traveling into the past is actually possible. And we don't even know whether, once we finally understand all of this, our entire picture of reality will look anything like it does today. Maybe someday we'll learn how to control time in ways we can't even imagine. Maybe we'll be able to travel incredibly far into the future. Maybe one day wormholes will turn out to be more than just mathematical ideas. Or maybe nature has a deeper rule that will forever keep us from traveling backward. But for now, there's one thing we know for sure. Time is passing for all of us, right now, and the strangest part is, we still don't fully understand what passing even means. Maybe the biggest mystery in the universe isn't the most distant galaxy. It isn't the biggest black hole. It isn't even the beginning of the universe. Maybe it's something that has been with us since the moment we were born. Something that stays with us until the very last moment, but that we still can't explain in simple words. Time, something we can never stop, and maybe something we can never turn back, but we can try to understand it. And the more we learn about it, the more we realize just how much we still have left to discover. So maybe the real question isn't, can we travel through time? Maybe the real question is, if we ever could, where would we go first? The past or the future?